See.
So we'll continue with last week's topic of bedside calculation. Page number 233 onwards, those who have the textbook. Page number 233 onwards. So the first formula is about the Holiday and Segal formula for energy and fluid requirement. This is how it is calculated. The total maintenance here, water requirement, is compared to the energy that the child has spent. Okay, the calories the child is burning, based on that the water requirement is calculated. It's usually 1 ml per calorie that the child has like spent. Okay, for example, if the child is burning around 1500 kilocalories on a daily basis, 1500 ml, that is 1.1 liters of water, has to be taken by the child, or fluid, 1.5 liters of fluid has to be taken by the child. Okay, so it's not suitable for neonates who are less than 14 days old, and conditions associated with abnormal losses like diarrhea and all. Okay, so in such cases we cannot apply this, but otherwise, okay, this is how we calculate the water requirement, fluid requirement, and energy. How much energy has been spent is equal to the fluid the child has to take. Okay, so 0.0 to 10 kg of weight, if that is child's weight, then 100 ml per kg. Above 11 to 20 kg is the child's weight. Okay, 1000 ml, 1 liter, plus 50 ml per kg for each kg. Okay, and if especially if it is less than 10 kg. Okay, and more than 20 kg if it is the child's weight, 1500 ml plus 20 ml per kg for each kg. But this should go only up to 20 kg, not more than that. This is the Holiday and Segar formula for energy requirement. Next is the bedside calculations for weight and height nutrition requirements. So here we use the Veach's formula. Veach's formula we have discussed many times. Okay, if the child's age is around 3 to 12 months, what is the expected weight? Age in months plus 9, the whole divided by 2. Okay, this is the Veach's formula. If the child is 1 to 6 years of age, expected weight should be the age of the child in years multiplied by 2 plus the whole number divide plus 8, add 8 to it. Okay, then 7 to 12 years, that's the age, then 7 multiplied by 7 minus 5 divided the whole divided by 2. Okay, so this is the Veach's formula. Veach's formula we have discussed many times. Okay, that is also used to calculate the height, weight, and nutritional requirements. This is the coefficient of calorie requirement. So if the child has an ideal weight, underweight, overweight, okay, how much kilocalories per kg per day they should take? Okay, it is completely based on their weight. Okay, so if the child is overweight, just 20 kilocalories per kg per day has to be ingested. If the child has the ideal weight based on their height and age, 30 kilocalories per kg per day. If the child is underweight, 40 kilocalories per kg per day. And if you're dealing with an elderly person, now we have to just focus on children. Okay, elderly persons, we don't have to think about it. It's a child nutrition class. So children who come under the age 1, okay, first year of life, 1000 kilocalories they should take. For girls, 1 to 12 years, 1000 kilocalories plus 100 kilocalories per year of that age group up to 12 years. For example, 1000 kilocalories by first birthday, 1100 kilocalories second birthday, 1300 kilocalories by third birthday, and so on. Okay, up to 12 years, this is how you add 100 calories per year up to that 12th birthday. Okay. For boys, the calories is slightly higher, 125 kilocalories you have to add every year for the age after 12 years. Next, we have the food guide triangle or food guide pyramid. The food pyramids are very commonly used even if you have seen the menu planning chapter of dietetics. If you have seen the recorded sessions, we have discussed in detail about the food pyramid. Uh, the cereals and pulses comprise they have the largest chunk of the food pyramid. Okay, specifically in Indian diets. Then comes vegetables. 25% of your plate should have vegetables. 20% should have fruits. So combined vegetables and fruits combined, it's around 45% more than what cereals and pulses you eat. Okay. Meat, fish, milk, eggs, the protein sources, 15%. Fat and oil, sugar, including sugar and sweets, should comprise only of 20%. This is the food pyramid or food triangle. Nutritive value of raw food items. Uh, there are tables given regarding these two topics, raw food items and cooked food items. You can check the tables. A lot many tables they have mentioned in this particular chapter. For raw food items, table 22.12 on page number 244 onwards. 244, 245, 246, 247. It's a big table up to 48. Nutritive value of raw food items. Okay, you can refer that page number. Per 100 gram, what is the nutritive value of raw, uncooked, okay, raw food items they have mentioned here. And nutritive value of cooked food items. Page number 248 onwards. Table 22.13 A, table 22.13 B. Page number 248 onwards. This is cooked food. And it is not, no, the cooked food is not 100 gram, only if it is specifically 100 gram, they have mentioned it. Otherwise, they have given the count or the cup value of it, a teaspoon value of it, they have mentioned. You can refer that. So nutritive value of raw foods and cooked food. Yeah, the uncooked food table, each uncooked food, they have taken it as 100 gram. For every uncooked food, they have taken it as 100 gram. Cooked food, they have mentioned exactly what is the quantity just next to it. Then you have the My Food plate. So it's a very practical approach for including all the food groups. Just looking at the My Food plate, you can see in this image, fruits and vegetables, they constitute at least half of your plate. Then 1/4 is grains. The remaining part, a little bit less than 1/4 is protein. Okay. Then you have dairy separately. That's also another source of protein. So the plate must be completed at least on a daily basis, and 5 to 6 days a week. This one, My plate, has to be followed for growing children. In USA, the My plate system works for the school diet, the school-based diet, whatever food the children get from school, they follow the My plate diet. Next, we have the Rainbow Revolution and the Rainbow Diet. So here, after green revolution for cereals and white revolution for milk, blue revolution was done for fish. Rainbow revolution is now popular among all the vegetables and the food items consumed according to the color, like green, yellow, orange, red, Okay, and fruits and vegetables for micronutrients and antioxidants. Okay, so brown color is for whole grains and multigrain. Brown roots, tubers for energy. Purple color is for proteins, legumes, nuts, meat groups. White is for dairy products, fat soluble vitamins, calcium, phosphorus. Here you can see different colors of fruits and vegetables are also can also be put into the rainbow color. So tubers, vegetables, carrot, yellow and red will have all the fruits and vegetables rich in beta carotenoids. Okay. Greens are all the green leafy vegetables, avocados, capsicums. Green farming is also another intervention. Now it is ongoing, which uses very less amount of chemical fertilizers and pesticides. The basic concepts of using a rainbow revolution in diet is you should be very liberal with the utilization of colored vegetables and fruits to prevent any hidden deficiency or micronutrient deficiency. That we have balanced diet. So a balanced diet is the one which supplies all nutrients in the right quantity and proportion. It is essential for growth, to maintain good health and prevent deficiencies. So carbohydrate should yield around 55 to 60% of energy. Protein should give 15 to 20% of energy, and fat should give you 30 to 35% of energy. And all the food items should be included in a balanced diet as per what Indian Council of Medical Research has recommended. And then extra nutrients during pregnancy and lactation, whatever the mother's baseline requirement is, okay, based on her body proportions, a pregnant woman, okay, whatever her body proportions are, the baseline nutrition has to be met. On top of it, from the third trimester onwards, she just have to add 300 kilocalories for during when she's pregnant, that too in the third trimester, not in the first and second. And that is one meal, add one more meal to the pregnant woman's diet in the third trimester. And then when she is lactating, 500 kilocalories, that is two meals, additional two meals a day should be added when she is lactating. Okay, the baseline calories is whatever her weight maintenance calorie is. Okay, on top of that, just 300 kilocalories when she is pregnant, specifically during the third trimester, and 500 kilocalories when she is lactating. That is two meals. 500 kilocalories means almost two meals a day has to be increased. So that's about the bedside calculations. If you have any queries, mention in the chat box. Digestion, absorption, and food processing, chapter 23, page number 259 onwards. For digestion and absorption, all the three major nutrients like carbohydrates, fats, and proteins, they get their initial stage of digestion through hydrolysis, which uses enzymes, and only after hydrolysis they can be absorbed. Okay, so there are three stages of digestion: luminal digestion, mucosal digestion, and mucosal absorption. Luminal digestion is where the hydrolysis is taking place. Okay, the enzymes are working, the bile salts are working. So that part that happens in the duodenum. Okay, so that part is called the luminal phase, the stage where the dietary fats, proteins, carbohydrates gets hydrolyzed with the help of enzymes and bile. Okay, after that comes your mucosal digestion and mucosal absorption. So in mucosal digestion, enzymes are present, but these enzymes are not flowing with the food. The enzymes are bound to the membrane of the intestine. Okay, they don't flow with the food. Okay, the enzymes that flow with the food happens at the duodenum. Okay, pancreas will secrete these enzymes, and the bile salts are secreted by the liver and gallbladder, and they get mixed up with the food, they flow with the food, they move with the food. That is luminal enzymes. Okay, but in membranous phase digestion or mucosal digestion, uh, occurs can only take place if only hydrolysis have already been done. Okay, with the help of enzymes, hydrolysis has been done. The next step is membranous digestion or mucosal digestion. So in mucosal digestion, enzymes are present, but the enzymes are not flowing with the food. The enzymes are on one part of the enzyme is stuck to the intestine's membrane. Only the other part of the enzyme is free to digest the food that is moving in the small intestine. Okay, the jejunum and ileum part of it. And absorption takes place after it is digested with the membranous enzymes. Then mucosal absorption will take place. Active or passive absorption can take place. So digestive enzymes, the different digestive enzymes, we'll discuss about them briefly. Salivary glands will secrete saliva, which has salivary amylase. Okay, the another name for is stylin. P is silent stylin. Okay, alpha amylase or salivary amylase. It has lingual lipase as well. So these are the enzymes present in saliva, which helps in the digestion of carbohydrates, not proteins, not fats, only carbohydrates. In the stomach, you have gastric glands that secrete hydrochloric acid, pepsinogen, intrinsic factors, and mucus. Okay, and pyloric glands secrete mucus, gastrin, small quantities of pepsinogen. So pepsinogen can be converted into pepsin with the help of hydrochloric acid, and the pepsin is able to work as an enzyme. Gastric juice contains very small amount of lipase and gastric amylase, but it is not sufficient for the fat digestion. Fat digestion cannot take place in mouth or stomach. It only takes place in the presence of lipase. Then after the stomach comes a pancreatic juice, which contains amylase, lipase, proteolytic enzymes. Like proteolytic enzymes means the ones that will break down proteins. Amylase will help in breakdown of carbohydrate. Lipase will help in the breakdown of fats. Proteolytic enzymes like trypsin, chymotrypsin, carboxypolypeptidases, okay, they all help in the breakdown of protein. Ribo and deoxyribonucleases. So these all are proteolytic enzymes. And also bile salts are secreted. Salts help in the emulsification of the lipids, that is fat. Only after emulsification, lipids or fats can be absorbed. So carbohydrates, mostly polysaccharides, disaccharides, monosaccharides. Okay, the tyline enzyme that is present in the saliva, salivary amylase, gastric amylase, and pancreatic amylase, they can hydrolyze starch and polysaccharides into maltose. After maltose, it can be further broken down into glucose. Then glucose can get absorbed in the intestine. Disaccharides can be split into lactase, sucrase, maltase, isomaltase. Amylase can also help in the breakdown of resistant starches, amylase resistant starches to an extent. So lactase, tyline, maltase, amylase, these are the enzymes required for the breakdown of hydrolysis of carbohydrate. Coming to fats, lipases, okay, lingual lipase, that comes from the mouth. will not break down the fat, but it will help in dissimulation of fat. Gastric and milk lipases, bile salts, pancreatic lipases. These are the enzymes required for the breakdown of fat, emulsification of fat, and then breakdown of fat. Only emulsified fat can undergo breakdown. Emulsification means big globules of fat gets once they react with bile salts, they form into small globules of fat. Okay, these small globules of fat are easier to be broken down or hydrolyzed. And once the hydrolysis of fat takes place, you get fatty acids, monoglycerides, triglycerides, etc. Proteins, pepsin, you require pepsin to break down protein. Then trypsin from pancreas, chymotrypsin. Okay, only then you will get amino acids and polypeptides. Again, peptidases is required to break down polypeptides as well to make more amino acids. Okay, so the main enzymes required, main chemicals and enzymes required for the breakdown of proteins are pepsin from the stomach. So the protein digestion takes place in the stomach. Trypsin and chymotrypsin and peptidases from pancreas. Okay, so that further digestion takes place, so that we finally can get amino acids, because the small intestine can only absorb amino acids. So is it clear regarding the digestion and hydrolysis of macronutrients? What all enzymes are required mainly in this digestion? Yeah, only be aware of the enzyme names, from where it is secreted, and for what hydrolysis it is required. Hydrolysis will take place for everyone. For carbohydrates, fat, and protein, hydrolysis will take place. But which enzyme secreted from where is required for this hydrolysis is important to know. Next, coming to the cooking, processing, and storage. So, cooking improves the digestibility, taste, flavor, and appearance of all food. There are different forms of cooking: boiling, okay, steaming, pressure cooking, frying. So if you boil for too long, uh, you will lose a lot of nutrients, specifically water soluble ones. Steaming will not cause much loss of nutrients. It's a very good way of saving the nutrients. Pressure cooking retains nutrients as left of our water is very little. Okay, frying, only if you're sauteing, it's good. But if you're deep frying, it's not good. Okay. Shallow fry as much as possible instead of stir frying. Simmering is good, specifically if you use cast iron vessels. Simmering is good. Then we have fermentation. It enhances the vitamin C value and increases the digestibility. Nutritional yeasts are also a good source from fermentation. They are good sources of vitamin B12 for vegans and vegetarians. Then precautions while using the vegetables and fruits: use only fresh vegetables and fruits. Consume raw vegetables and fruits whenever possible with their peels, because it's good in fiber. Wash before cutting, and do not wash after cutting, because water soluble vitamins will go, vitamin C will go. Cut them only at the time of cooking and eating. Don't cut them and store it for a long time. You will lose vitamin C. Do not soak them for a long period of time. It will lead to loss of vitamins and minerals. Peel the vegetables carefully, usually after cooking, because in that way you will retain more vitamins and minerals. Green leafy vegetables and the colored leaves of the vegetables should not be discarded. It can be used for smoothies as well. Avoid overcooking. Washing the food, wash food items with clean water to remove dirt, bacteria, any worm eggs. That is helminthic egg, ova means worm eggs. Okay. Storage, cereals, pulses, etc. should be stored in clean, tightly covered containers. Vegetables should be stored in cool, dry place or in refrigerators. In dry, open baskets. Pickling increases the life. Parboiling, this is an ancient Indian method used for steaming and all, steaming the rice and all. Okay. So parboiling improves the shelf life of rice, and it avoids the destruction of rice or any other cereals through because of insects. So it's a good method of cooking cereals. Then amylase resistant starch and and cooling of foods. So amylase resistant starch are a kind of carbohydrates that will not allow the effective hydrolysis with the help of amylase. So they remain undigested and they get fermented in the intestine and they form into short chain fatty acids. So so all the food that has ARS, amylase resistant starch, since they are not getting digested quickly, because if hydrolysis is taking place quickly, it will be absorbed very quickly. But amylase resistant starch food, they are not getting digested. They stay in your stomach, they stay in your intestine for a longer period of time, and they increase your glucose levels in the blood very slowly. So glycemic load is very low in this food. Good for diabetics. Okay, people who have diabetes. See, in pickling, you use a lot of spices and all. Okay, in fermentation, uh, the way how you get curd, okay, is that's a form of fermentation. It's not pickling. Okay. In pickling, you use spices, use vinegar. Okay. Additionally, you put things so that it stays like this for a longer period of time with addition of certain bacteria. But in fermentation, the food's own bacteria will make the changes. We add salt for its bactericidal effect. Pickling, we do the pickling of vegetables so that it can be used for a longer period of time. So examples of food that are rich in amylase resistant starch are unripe green bananas, sweet potatoes, whole wheat. These all are good sources of amylase resistant starch. How to improve the nutritive value of your food? Soaking. I would not recommend you to soak nuts like almond, walnut, and all those things, dates, etc. You do not have to soak them. The only thing that can improve the nutritional value with soaking is your legumes and pulses. Okay. Soaking is effective for legumes and pulses, not for nuts. Nuts and berries, you eat it as it is. It's completely fine. It will give you the same nutrition as others. Okay. So soaking in water sometime will initiate the enzyme action and germination. It increases the vitamins, digestibility, and also makes cooking easier. Soaking of rice and black gram before grinding for idli is a good practice. All legumes can be soaked before cooking, like rajma, beans, kabuli chana, black chana, peas, etc. Then malting, soaking some cereals like ragi overnight and then drying them in the sun, and then powder, then you grind them. Okay, then using it as ragi malt. Okay, malting is a good practice. It improves the digestibility also, and enhances the use of vitamins from the intestine. This is what we call it as malting, making the grinding the ragi into powder. Okay, sometimes in for babies, what we do is we sprout the ragi first. Okay, ragi is washed nicely with water. Then you have to allow ragi to sprout for at least 2 days. Then you dry the sprouted ragi. You have to dry the sprouted ragi in sun, and the sprouted ragi is then ground. Okay, that enhances the ragi's nutritional value. Then sprouting or germination. So that will again increase the digestibility, increases vitamins, reduces the bulk on cooking, and it decreases the phytate levels also. And it's a good source of protein as well, sprouts. Then amylase rich food. How can you make a cereal amylase rich? So wheat, bajra, jowar, moong dal, okay, they all can be converted into ARF, amylase rich food. How do you do it? You can the example which I have shown on screen is just for wheat, but you can follow the same practice for bajra, jowar, ragi, moong dal, etc. Okay. So take 250 gram of wheat, add 2 to 3 volumes of water into this 250 gram of wheat. Okay, 2 to 3 times of water into this. Soak it for 8 hours. Drain out the excess water and germinate it in dark room. Okay, that is sprout the wheat in dark room for 24 to 48 hours. Then sun dry it for 5 to 8 hours. The same thing that I told about malting. Okay. Then you have to roast them gently in a flat pan, just so that you get rid of the excess water. Because if you grind them with water, you cannot store them for a long time. Okay, so after sun drying, just gently roast them for a little bit of time so that you are sure that all the water has been evaporated. Okay, then you grind them into powder. Okay, and then store them in airtight bottles or jars, and it can be used for a longer period of time. And you can use this for children, for feeding the child, and for weaning the child. Okay, for weaning that, it's a really good practice using a amylase rich food. This you can use for moong dal, bajra, jowar, ragi. Okay, soak them, sprout them, sun dry them, roast them gently, grind them at home properly, and store it in airtight jars. Okay, use it on a daily basis. So this is how you make a amylase rich food out of your regular attas, etc. Okay, so is it clear to all? And swelling of food items and high density food. So the foods that do not swell on cooking or boiling, okay, they are high density food. For example, egg, potato, banana, etc. They don't change drastically when you cook them. Okay, their size remains more or less same even after you boil them or cook them. So that is a high density food. Okay, so all the food that swell a lot after you cook, for example, rice. Okay, rice will swell a lot after you cook. It will become 3 to 4 times of its original size when you boil them. Okay, so it's a low density food. Okay, rice, dal, etc. They all are low density food. It can increase its size 3 to 4 times after you cook them. Okay, so they are considered as low density food. So when you add the ARF powder at the end of the cooking, it can reduce the bulk of the cooking, especially when it comes to infant food. Okay, give them small amount of rice and put ARF powder on them, so you can reduce the bulk of it. The child will not consume a lot many food. A small portion of food the child will consume, and the child will be completely filled with the food. Okay, the child will feel satiated with the food. Okay, that is the use of ARF powders. So even on a daily basis, you can you can practice this. Okay, white rice instead of white rice, go for brown rice. Instead of white bread, go for whole bread, whole multigrain bread. Sandwich with processed meat, go for roast chicken sandwich with multigrain bread. Sweet candies, go for fruits. Potato chips, go for nuts and seeds. And vanilla ice cream or any ice cream, you go for plain yogurt with fruit. These are the healthy choices you can do on a daily basis for the kids as well. So that's all for today. If you have any queries, you can mention in the chat box. It's about different types of cooking, what the nutritional value, the digestion of food. Okay.